Good day. This is my video submission for our POE for 2026. I will start by showing the containerized solution running in Docker Desktop. You see three containers: SQL Server DB running 2020, running SQL Server 2026, GLMS Backend API, which is the REST API on port 5000, and then we have GLMS Frontend Web, which is the MVC app on port 5001. All three are running and healthy. The entire stack was started with a single command, docker compose up. The containers start in a specific order enforced by the docker compose configuration. The database starts first. The API then waits for the database to pass its health check before starting. The web app waits for the API. This is controlled by depends underscore on with condition service underscore health, which is which I will show in detail later. Get API contracts returns 200 okay. Oh, 200 successful with a JSON array of all contracts. The contract controller delegates to I control repository, contracts repository, which runs an entity framework query that includes the related client data. That is why you can see the client name in the response. Let us execute and see all the data right here. If the request for an ID does not exist, like 99,999, then the API returns 404 not found. The system gives the correct HTTP status rather than returning empty data or crashing. Switching to the web UI, the same contracts appear in the search contract list. The the web app did not query the database directly. Admin control called the API contract service .get all async, which made an HTTP gets to the same API endpoint as I just demonstrated. I set I set ID to 0. This was intentional. The database is configured as an identity column, so SQL servers assign the real ID on insert. You can see the system generated ID in the response. The response code is 201. The correct HTTP code specifically for a newly created resource, not 200. Video demo 001 has appeared in the web UI. The MVC app has no direct database connection. Admin control cold API contract servers create a sink, which made an HTTP post to the API. The web app and API share the same data through the API layer. It replaces the entire contract. I changed the status to inactive and updated the description. The response is 200 OK with full updated contract returned. The web UI shows the updated status. Fetch does a partial update. Only the status field changes, nothing else. This is more efficient than put. When I only need to change one priority, I send just the single field I want to update, not the entire object. The response is 200 success. Back in the web UI, the status is updated to active. Delete returns 200 success. Puts a confirmation message. And it is deleted. Trying to delete a contract that does not exist returns error 404. The repository checks whether the record exists first. If not, it returns false, and the controller responds with 404 rather than throwing a handling exception. Here on the list, you can see that video demo 001 is gone from the web UI. Now I will walk you through the source code to explain the architecture, specifically repository patterns and separation of concerns. This is iContract repository, an interface that defines the operation of contracts. Get all async, get B, BYID async, create async, update async, and status async, delete async. This is the contract. The rest of the application depends on this abstraction, not any specific implementation. Okay. Contract repository is the only class in the entire solution that uses application DB context. The only place where the entity framework and the database are touched. All the queries, all the include all the include statements, all the save changes asyncs, call live here and nowhere else. If I wanted to switch from SQL Server to Postgre, PostgreSQL Server, PostgreSQL, I would create a new class implementation. The same interface, change one line in the same in. I would create a new class implementing the same interface. Change one line in program.cs and nothing else would need to change. A contract controller receives iContract repository through the constructor. It never creates repository itself and never references contract repository by name. This is a dependency injunction. The controller declares what it needs and the framework provides it. The controller cannot tell whether data comes from SQL Server or in-memory database or a mock. One line that connects the interface to its implementation, add scope, means the ID container creates one instance per HTTP request. The contract lifetime for a database context. The separation of concerns works across all three layers. View handle presentation, service handle business logic, repository handle data access. Each layer only communicates through interface. Look at this file carefully. This is no using s- there is no using statement for entity framework. There is no application DB context. There's no DB, there's no underscore DB field anywhere in the class. The only dependency is HTTP client. Every single method makes an HTTP call to the REST API instead of querying the database directly. The web app is completely unaware that a database even exists. API auth handler sits visibly between the web app and every outgoing HTTP request. Before each request is sent to the API, the handler automatically fetches a JWT token and attaches it to a bearer authorization header. Control hmm, Controls in the web app never deal with the token manually. It happens entirely behind the scenes. This single line wires everything together. It is it registers API contract services as the implementation of my contract service and chains API authentication handler so it runs on every outgoing request. Admin controls still inject iControl service exactly as before. It has absolutely no idea whether data comes from the API or database. Only this one. Where's this line? Only this one line changed. These are the automated tests. Top section is freight quest tests. Contains unit tests. They use an in-memory entity framework database, so no real SQL server is needed. They test contract services, filtering by search term and status. There is expired property on the contract model. PDF magic number validation in file service, which checks the actual bytes of a file to confirm if it is a real PDF and not just a renamed file. Data automation, validation of all models, and currency conversion. Lower section freight quest integration tests contain integration tests. These web application factors um, uh, these use web application factor to spin up complete real instances of API in memory. Actual HTTP requests are fired up and actual HTTP responses are checked. Nothing is mocked at the HTTP level. FreightQuest API Factory replaces SQL servers with an in-memory database, replaces JWT authentication with a test auth handler that always returns authenticated and sees test data. The test verifies 200 for success, 201 for the valid post, and 400 for invalid data, and 404 for missing resources. All pass.